Good day everyone. My name is John Kevin Dadan,
And I am Zyth Bantillo.
and we are the proponents of the research proposal entitled Solar Thermal Power Generation Plant for Kabasalan, Zamboanga Sibugay.
So, Chapter 1, The Problem and its Scope. Introduction. Solar thermal, also known as solar heating, harnesses the energy provided by the sun to provide thermal energy to heat water. The hot water produced by the solar heating can be used to supplement domestic hot water, although the temperature might need to be top up by the boiler. Larger stores of water like swimming pools, underfloor heating, and space for heating or cooling.
The rationale of the study. Those with long memories will remember that the Philippines has been here before in the dark days of the early 1990s. The 1986 ouster of President Marcos led to the cancellation of a controversial nuclear power plant, and no new capacity was built, leading to day-long outages that stalled the economy. The Ramos administration solved the problem through emergency powers granted by the 1991 Energy Crisis Act to conclude contracts for the new power generation. Those with new memories do not go back to that far might know that this looming energy crisis has been predicted, and general concern for electricity supply and price has been a feature in the Philippines for many years.
Statement of the problem. What is the general average of the electricity consumption cost of municipality of Kabasalan, Zamboanga Sibugay for the months of July to December 2020? What is the estimated cost of construction for this power plant and the return of investment ROI in years? What will be the expected power produced in terms of kilowatt and the cost of this power to be used by the community, this power plant?
So, for the significance of the study, the result of the study will be beneficial to the district of Kabasalan, Zamboanga Sibugay, the environment, the students, and other researchers.
The environment. The sun provides tremendous resource for generating clean and sustainable electricity without toxic pollution or global warming emissions. Solar energy system power plants do not produce air pollution or greenhouse gases. Using solar energy can have a positive indirect effect on the environment when solar energy replaces or reduces the use of other energy sources that have larger effects on the environment. Developing renewable energy sources conserve reserve of fossil fuels and reduce the long-term price of fossil fuels from conventional sources.
The students. This study will also be beneficial to students, especially electrical and mechanical engineering students, because they can have their on-the-job training to learn and study the concept of the solar thermal power plant.
Researchers. This study will also be beneficial to the researchers who are studying on topics related to solar thermal. The content of this study can be used as a reference for their research.
For the scope and limitation of the study, this study will only cover the district of Kabasalan, Zamboanga Sibugay, including all 29 barangays and a total household of 9,473 with a total population of 44,336. Since the pandemic is still going on, we have not gained information on the monthly electricity bill of the Kabasalan district, so the researcher came up with the idea of assuming the usage of electricity in Kabasalan is 24 hours a day and a 30 days per month, 12 months a year. So the electricity harnessed from the sun using heat and will be the outcome of the study. Anything beyond that will no longer be part of the study. This can only be included in the recommendations for further studies.
Theoretical framework of the study. The study is based on the theory that When a photon is absorbed, its energy is given to the electron in the crystal lattice. Usually, this electron is in the valence band. The energy is given to the electron by the photon excites it into the conduction band where it is free to move around within the semiconductor. The network of the covalent bonds that the electron was previously part a part of how of now has one fewer electron. This is known as a hole. The presence of a missing covalent bond allows bonded electrons of neighboring atoms to move into hole, leaving another hole behind, thus propagating hole throughout the lattice. It can be said that the photons absorbed in the semiconductor create electron hole pairs. Flowchart: collector collector to storage collector to storage to, to boiler to heat engine. Heat is rejected and mechanical energy goes to the generator to become electric energy and waste. So as you can see in the figure, the flowchart says collector to fluid, steam, mechanical energy to electric energy. So at the bottom side is thermal energy, thermal energy goes out, heat rejected, and water heat. So inside the box are collector system, storage, boiler, heat engine, and generator. The solar energy obtained and converted to heat by the collector system is transferred by the thermal fluid to the storage and further to a boiler, where steam is generated. Further steam is applied to the turbine in the heat engine, where it is converted to mechanical energy, while some heat is rejected. If the, elec- if the electric power is desirable output, the mechanical energy is applied to a generator, where it is converted to electricity. At each conversion step, we can expect some losses due to non-100% efficiency.
For the conceptual framework of the study, so this study focuses on the concept of a cheaper and more efficient energy source from the sun that can be harnessed to be used daily to sustain our energy demands. As time goes by, it is inevitable that our global population grows exponentially and the technological innovations advances too fast too. Therefore, it is imminent that the energy demand rises so fast globally and the energy from the sun is almost unperishable that it is obviously a great energy source to sustain our energy needs. So the primary source of energy is the sun, and through the solar thermal power plant, electricity will be produced to be sent to the electric cooperative, which will be distributed to the municipality of Kabasalan, Zamboanga Sibugay, and the excess electricity produced will be consumed by the neighboring municipalities. The power produced by the solar thermal power plant will then be sent to consumers by the electric cooperative. This energy should of course be paid by the consumers and will be the source of the return of investment of the power plant. This will be a profitable business after a certain period of time. So, as shown in the figure, it is a flowchart. So the electricity or the energy coming from the solar thermal power plant goes to Samsoreco 2, which is the electric cooperative or the electricity provider of the Zamboanga Sibugay, and it and they distributes the power to the municipality of Kabasalan. So this figure is entitled the new electrical source for Kabasalan, Zamboanga Sibugay.
Research methodology. First in the process is the data gathering of the general average electricity consumption of the municipality for the months of July to December 2020. The months that are included is during the COVID-19 pandemic, where people mostly stay at home and increase the expected electrical energy consumption. This data gathered will illustrate the trend in electric consumption of the municipality. The researcher will go to the Samsoreco 2 office in Santa Clara, Naga, Zamboanga Sibugay to request for the data to be computed. The important data to be considered is the energy in kilowatt per hour consumption of the municipality.
So the solar thermal power plant is proposed to be constructed in Timoy Danda, Kabasalan, Zamboanga Sibugay. This area is great for the construction of the power plant since it is spacious enough for the construction. The cost of construction of this power plant will be based upon the data gathered by the researchers, which is the energy consumption of the municipality. So how much is the consumption of the municipality is also how large the power plant to be constructed that could sustain the municipality's electrical demand. The same goes for the ROI to be computed.
The expected power produced by the power plant will be computed using the proposed size of the power plant to be constructed. The expected power produced should not only be equal to the computed electrical consumption of the municipality. The energy demand increased fast and there should be no worry for the excess energy produced, for it will supply the neighboring municipalities.